Hello everyone. So this is the session number 5, system of equation. In this session, you will learn how to solve the system of simultaneous equation by a matrix method. So first we'll consider here the system of non-homogeneous equation. Now, what is this non-homogeneous equation? One of the example is here. You will observe these two equations are known as a simultaneous equation. Our aim is to get the values of x and y which satisfy these two equations at the same time. That is known as a solution of a simultaneous equation. Right now, if you observe in the left hand side, there is variable x and y whose degree is 1. So LHS is a with a degree 1. Left hand side have the degree 1, while the RHS is a constant and the constant term is considered with a 0 degree. So it is a non-homogeneous system of equation. So whenever we have a non-zero constant on the right hand side, it is considered as a non-homogeneous system. So this is one of the system of equation. So this is not new to you. In your school days, you solve this system of equation by method of elimination. For example, if I give you say x plus y is say 10, okay, and I say x minus y is say 5, and if I ask you find x and y, so you can easily say let us add these two equations. We get 2x equal to 15, so x become 7.5, and then you can substitute this 7.5 in one of the equation and you can get y equal to 2.5. So this is the method of elimination. Yes, this is the simplest method that we have, but the drawback of the method of elimination method is when there are more number of equation, more number of variable, it becomes so complicated. Okay, so we will move to the matrix method, but before that, one of the method I shown here is a graphical method. Now, why this graphical method is important? To understand the types of solution only. How many possible solutions are there for the system of non-homogeneous equation? If we plot these straight lines, see linear equation represent the straight line in xy plane. So for two variable, we can draw this straight line easily. So for both these two straight line, it is observed that these two straight line intersect at a single point only. See, this is one of the straight line, this is the other straight line, and they intersect at 3, 2. So we can say in this case, the system have a unique solution, only one solution. That is a case 1. Okay. The case 2, if we take for case 2, suppose I take a simple equation, say x plus y is equal to 1 and x plus y is equal to say 10. Now, obviously, you will observe there is no any pair of x and y which gives us the addition 1 and 10 at the same time. It is impossible. So what happens when you plot the graph? The graph becomes a parallel here. You will observe the first straight line and the second straight line. These are parallel lines. They are not intersecting at any place. When the lines are not intersecting, there is a no solution. See, case 1 was a unique solution when it intersects in a single point. When the lines are parallel, there is no solution. And the last case, if we have equations like say x plus y is equal to 1 and say 2x plus 2y is equal to 1, so indirectly, so these two equations are the same equation, so we get overlapping lines. So lines are coincident, so we say infinitely many solution. Okay, so case 3 is an infinitely many solution. So in simple words, the graphical method helps us to understand types of a solution. When the lines are intersecting in a single point, unique solution, lines parallel, infinite solution, lines are coincident. Uh, um, sorry, my mistake if I said. So when lines are intersecting in a single point, unique solution, lines are parallel, no solution, and lines are coincident, infinitely many solution. Again, the drawback of this method is useful for up to the two variable. Whenever more than two variables are in the equation, graphical method becomes very complicated. We are not able to plot their graphs. Okay, just in three-dimensional also we have to plot that planes, and that becomes too much complicated there. So we'll move here to the types now. Whenever we have the system of equation and that system of equation have a solution, suppose that solution is infinite solution or unique solution, we say that system is a consistent. So what is a consistent system? What is a consistent system? The system of equation which have a solution any type, either no unique solution or infinite, then we say consistent. But If the system has no solution, we say the system is inconsistent. So in non-homogeneous case, we have three cases: unique, infinite, and no solutions. Out of that, that unique and infinite considered as a consistent, and no solution is considered as inconsistent. Now, for simplicity, consider the system of three equations in three unknown. Now, what are unknowns? Unknowns are the variables x, y, z. Okay, so these are the variables whose value we don't know, that we have to find out. So number of unknowns in the system we denote by the letter n. N is the number of unknown, and in this case n is a 3. Okay, 3 is the number of unknowns. So every system of equation, which is given in this form, yes, we can convert it in the matrix form. So we can write it's a coefficient matrix. Say the coefficient matrix, see these same equations I can write in this form. So first row, it is a A11, A12, A13, A21, that is a, sorry, A21, A22, A23, A31, A32, A33. So this is about the coefficient matrix, coefficients of this one. Then the matrix of unknown, which is x, y, z, and then the RHS is B1, B2, B3. So that is in the form of Ax equal to B. You'll observe when you do the row, this matrix multiplication, this row by this column, you'll get first equation, this first equation like A11x plus A12y plus A13z equal to B1. So this is the way actually the system of equation we are converting in the matrix form, that is Ax equal to B. Remember, when these B values of Bi are non-zero, it is a non-homogeneous system. But when Bi's are zero, this is the homogeneous system. So this is another important thing that you should remember. Okay. Now, in a solution, this augmented matrix plays an important role. This augmented matrix is a matrix which is obtained by joining the matrix A with a B. So we denote A colon B. A colon B is a matrix, and this matrix is nothing but this is the coefficient matrix A, and just we added the column of the RHS, and that is augmented matrix B. Now the rank of this augmented matrix plays a very important role in the type of a solution. Depending on the rank of A and the rank of AB, we are going to tell that whether the system have a unique solution or infinite solution or no solution, and that conditions are here. So this is a very important slide. These conditions you have to remember. Whenever the first thing, I will come to the last point here. Suppose rank of A is not equal to rank of AB. Not equal, no solution. Just remember, not equal, no solution. So if the rank of A and the rank of AB they are not same, then the system does not have a solution. So this is the case 2, this one. There is no solution. In that case, rank of A is not equal to rank of AB. But if everything is equal, say rank of A equal to rank of AB equal to number of unknown, then the system have unique solution. That about case 1 here, this case 1. Rank of A is equal to rank of AB equal to number of unknown. And the last case, rank of A is equal to rank of AB but less than number of unknown. The system have infinite solution. That about the case 3. So these are the 3 very important conditions. We are going to use it in each and every example to decide the type of a solution. So remember these important conditions. And now let me move to the homogeneous system and we'll discuss about which types of solution exists there. So in the case of homogeneous, I will write the equation, then you will understand it better. Suppose the equations are like this. Say x plus y is a 0 and x minus y is a 0, or the equation is like this. Say x plus y is a 0. My mistake. This is x minus y is a 0, and say 2x minus 2y is a 0. Suppose this type of the system of equation you are given. What will happen? You will observe for this type of system, there is always a solution. If you replace x and y by 0, so 0, 0, 0, 0, x is 0, y is 0, this will satisfy any type of this homogeneous system. Whenever RHS is a 0, Just replace x and y by 0, we get that. So this zero solution, this zero solution, this zero solution is also known as a trivial solution. Trivial means obvious solution. This is so obvious, no efforts were required to calculate it. So zero solution, trivial solution, this is also known as a unique solution because that is only one solution. You'll observe, you'll observe whenever the system is homogeneous, the straight lines always passes through the origin, that is point 0, 0. Okay, this point 0, 0. And there are now only two possibilities left because homogeneous system is always consistent because it have always a solution that is at least 0, 0 solution. Is that so? If you plot these two straight lines, you will observe they will intersect in a single point and we have unique solution. And when the lines are coincident, we have infinitely many solution. Okay, infinitely many solution. So exactly similar conditions now. When rank of A is equal to number of unknown, now there is no matrix B. See, RHS is a 0, so no need to consider the matrix B only. So if rank of A is equal to number of unknown, when the rank of the matrix becomes equal to the number of unknown, the system have a zero solution, trivial solution, or unique solution. The name is 0, 0 only. So just you can write x equal to y equal to 0 only. Okay, x equal to y equal to 0 directly. Or if rank of A becomes less than number of unknown, we have infinitely many solution, infinitely many solution. Another important thing that you will observe, the condition on the determinant. You will observe, just focus on the determinant of this matrix now. If you take determinant is 1, 1, 1, minus 1. If you evaluate this determinant, minus 1, that become a minus 2. Is it? But if you consider this way, this for the second case, this is 1, minus 1, 2, minus 2. If you consider this determinant, this minus 2 plus 2, that is a 0. So what is the important thing? Whenever we have infinitely many solution, that means we have non-zero solution. Whenever non-zero solution is determinant is a 0. This is the most important condition. For infinitely many solution, for non-zero solution, the determinant is always 0. This is the most important condition. This condition, remember this condition, determinant is a 0 for non-zero solution. This condition always we use to find out the value of a constant which are involved in the homogeneous system. So this is also a last important thing that you should remember. So when the coefficient determinant is 0, when the coefficient determinant is 0, the system always have infinitely many solution. So that also you should remember. Okay, so that about the conditions, that about the formulas that you should remember. The method, the name of the method that actually we are using is known as Gauss elimination method. Initially we have the matrix known as augmented matrix. It is augmented matrix provided it is non-homogeneous. If it is homogeneous, it is enough to take only the matrix A. Okay. So we have the matrix say A11, A12, A13, B1, then A21, A22, A23, B2, A31, A32, A33, B3. We have to use A11. Step 1 is we have to convert this augmented matrix to the row echelon form. And for that, we use A11 and we will make these two zeros. After that, we'll use A22 and we'll make this last entry 0. So automatically the matrix becomes in the row echelon form. Once we get in row echelon form, remember the last equation, because these three will be the zeros now. These three will be the zeros after row echelon form. Then this last one will give the value of z first, provided this is non-zero. So we'll take first, we'll get the value of z first. We substitute that value of z in the second last equation. We get the value of y then. First we get z, then y, and then x, and that is known as a back substitution method. We'll learn this detail with examples. Okay, when we see in the next session, we'll see the examples that becomes more clear. So the name of a method is Gauss elimination method. Whatever the method we are using here, that is a Gauss elimination method. In simple words, we reduce the coefficient matrix or augmented matrix to the row echelon form, and then by back substitution method, we can easily get the values of these unknowns. Okay, and here is the last thing. There are many more applications for the system of equation. Many more applications. Balancing chemical reaction. Balancing the chemical reaction. That is one of the application there for the system of equation. So many more, wherever the equations we can create, yes, that can be solved by the matrix method. Out of these, yes, two of these are the part of our syllabus: electrical network and the traffic flow. Okay, so this is just for your knowledge that there are many more applications for the system of equation. We'll see that in the one of the session there. Okay, so thank you. That about the theory of the system of equation. Okay, so bye.